In this diagram, you have a complex circuit. It is complex because you have both parallel connection, which is in turn in series with this. If you take this resistance out, there will be no current in the circuit whatsoever. If you take one of these, then that current will find a path. So if 6 is out, your path is going to be through 9 and 3. They will be in series. If you take 9 out, then your current will go through 6 and 3, and that will be in series. Again, the way it is connected right now, your current comes here, splits. Most of it is going through 6, and then some of it will go through 9, because current takes the path of least resistance. Then it fuses back together into one current. If I need to find the current and voltage on each single one of those resistance, here's the method. First, you're going to find your total resistance. R equivalent is a question. You always start sort of from the butt, as far away from the battery as you can, and you start building from the back to the battery. So my first cluster is this. This is very clear that it's in parallel. So you remember the equivalent resistance for parallel is all about reciprocal. So I have 1 over equivalent resistance, not for the entire circuit, but only for that particular cluster. 1 over 6 plus 1 over 9. Common denominator is 18. So you have 3 plus 2, which is 5 over 18. And mind you, that is not your equivalent resistance. Your equivalent resistance is always for parallel smaller than the smallest, 18 over 5. So that will be 3.6 ohms. So this entire cluster I could replace with one resistance. That's why it's called equivalent. I can take out this whole contraption and put another resistance of 3.6 ohms, and I will end up with a total resistance of being the same as if I had it in its entirety. So our equivalent for the entire system is 3.6 plus 3, because now these guys are connected in series, 6.6 ohms. This would be the same if I had this my 12 volt battery, 6.6, and the current in this case would be 12 over 6.6. That is 1.8. As our current starts right here, it will split into 2 and then back in here as 1. So this right here, the 3 ohms, will grab our 1.8 amps all to itself. With your hands on, you saw that that was the brightest light bulb there. How much voltage does it take to push 1.8 amps through a 3 ohm resistor? You multiply, right? V equals I times R. So you take 1.8 and you multiply it by 3 and you get 5.4 volts. So I have altogether 12 volts, and these 12 volts split into 5.4, which is taken just by this resistor right here. And then what is left over? If I take 12 minus 5.4, 6.6 volts, which means that between these 2 points, if I were to put my voltmeter in there between these 2 points, then I would get 6.6 volts, which is what goes to this resistor, meaning that the current of 1.1 amp goes up here, and you can do 2 things to figure out the current through the bottom. You can take 1.8 minus 1.1, which is 0.7, or you can also take 6.6 over 9, and that gets you 0.73. The more significant figures you keep intentionally, the more precise your answer will be. 1.8 amps was not entirely 1.8. It was 1.81818 forever. So it was technically 1.82. So don't panic if your total current, which in my case is 1.1 plus 0.73, is 1.83. But here I only had 1.8. That's because I rounded. If you follow the rules and find it correctly, then plus or minus significant figures is not going to break you.